Good morning, everyone. Can you hear me okay? Put something on the chat. No. Can you hear me okay? Yep, great. So Farhan is just joining. He's one minute away. So this is going to be very exciting discussion. But while we wait for him, and for as a bit of an intro, Farhan, he was a senior data scientist at Netflix and is now a senior data scientist at Apple. So obviously huge credentials, and it's great that he gets to join us. He did a PhD in neuroscience and has worked in both research and industry for a while, and those two being his latest and current roles. Let me see. He's saying that he is on. Great. So there we go. Mate, good to see you.
Good. How are you?
Yeah, very well. How are you going?
Fantastic.
Yeah, no, great. Thanks for making the time. I was just doing a bit of intro about yourself, and so the audience knows, and obviously PhD in neuroscience, working in academia and in industry, and worked at Netflix as a senior data scientist, and now in Apple as a senior data scientist. So thanks so much for making the time. And today we're going to be talking about effective data science. And as at least the audience knows, in data futurology, we discuss the decisions and the challenges that leaders in the analytics and machine learning and in artificial intelligence space are facing. And we want to bring you perspectives and have the discussion about how to proceed in those scenarios. So we are very excited to have Farhan on the show today. How are you going, mate?
Fantastic. Thanks for having me. It's a pleasure to be here, and I'm excited to share with you some of the insights. Hopefully it'll be useful for the audience.
Yeah, definitely. And for the people that are joining live, we have the Q&A section enabled. So please put any questions that you might have there. For the questions that pop up, anyone can give it a thumbs up and upvote them. So we start with the ones that have the most votes. We'll also use the chat for any other comments, any thoughts that you want to share. Definitely be active on the chat. And we have a poll as well, which with 3 short questions, which I might launch now, and we'll have about 10 minutes for people to answer the polls, and then we'll discuss the answers. So Farhan, could you kick us off? Could you tell us a little bit about your role at the moment, and a bit about how you got there?
Sure. So I've been at Apple for about 2 years now, in the search ads platform team. So for those of you who are iPhone users, and I hope it's a lot of you, if you go into the App Store and you go into the search, you'll find that when you're looking for an app, you do get a sponsored search result, which is an ad. And we work on a lot of personalization problems there to try to optimize the advertisement for your taste. So if you're a gamer and you're into car racing, or if you're a gamer and you're into strategy game, we hope that we would personalize that ad towards you. So that's one of the hats that I wear in my role. And then there's a significant part of my role that's also works on machine learning architecture experimentation. So that's been something that I've been doing even in my previous role at Netflix, where I was doing content demand modeling. We had a lot of models there, and we really had a problem of how do we deploy models efficiently. And in order to solve that one, I had built a model deployment framework. And so I tend to always have this kind of dual role where I'm doing some machine learning architecture as well as doing the sort of individual personalization or machine learning models.
Man, that is great, and definitely on the deployment side, there's so much activity going on in that space, and it's an area that is improving in Australia, but at least in Australia, we definitely have a while to go, and we've done polls in previous webinars asking about how many models organizations have in production, and the majority seem to be in the low single digits, and they point at the path to production as a key barrier. No, that's interesting.
I
Sorry,
think
any
one
thoughts?
of the things that ends up happening in a lot of organizations that are sort of either worldwide or they have a worldwide presence, it's an interesting problem where, you know, we always struggle between should we have a global model or should we have a local model? And it's both an algorithmic choice and it's also an operational choice. And a number of times each market is super different, and so you have to really tune your models towards a particular market. You may even have data sources that are different by market, and in those situations, it makes sense to have models that span across other countries. And so if that's the case, then you end up having this proliferation of models, and we've seen it, you know, in multiple domains. I was in consulting before Netflix, and there we would have, you know, 3-month projects in different domains. So I'd seen this happen a lot in the automotive space, in the telecommunication space, and so on. You know, you would have a client that was operating in, say, 140 countries. And, you know,
Wow.
you could group some of those countries together, but you still have that proliferation problem. But yeah, operationalization of models is definitely a huge area, and there's a lot of startup activity in Silicon Valley to solve this problem.
Yeah, definitely hot area, and for a lot of people, they think of the holy grail when they have to create so many models. They think about, you know, AutoML tools to help create them quickly, and obviously there the data availability and the data quality have such a huge role to play. But what is your view on AutoML approaches in general?
No, I think as ML matures, you know, it's becoming commoditized. So you have simple libraries, which basically means more people can come in and do some of the simple stuff that's easily sort of black box AI. In some ways, you can make a function call and you can get your prediction. And I think now more and more, even with architecture search and so on, with neural networks, you can have AutoML do a lot of things that are that work straight out the box. You have Google's Cloud AI that does even tabular data and competed in a Kaggle competition actually, and placed fairly well, not among the top, but fairly well. And so that was pretty impressive to see. So you know that this is coming, right? It's commoditized at this point, and it's going to the automation is coming, and it's going to get better and better. But one of the things that I think what ends up happening, and this gets back at what actually data science is and how to do effective data science. Part of that is how you combine you know, the domain expertise, the business acumen, those things that you get from the business that you can then apply to your machine learning when you're doing it for that particular business. And those are the subtleties that AutoML it'll be difficult to capture. Eventually, you probably would be able to capture, but they're sometimes difficult to capture. And these are things like, you know, how do you even we have even automated feature engineering. And there are times when there's essential business domain knowledge that's required for you to actually do the correct feature engineering that then, you know, will give you a good model. I mean, it's a classic thing of garbage in, garbage out. And the key thing that humans, I think, help doing, like a human data scientist will help you do, is actually to identify what garbage is when you're talking about the system, because that's when you know about the business and you understand the data, and then you are you know, you're using that knowledge to come up with inputs that are meaningful for the model. They'll then produce meaningful outputs.
Man, that is great. Such an awesome overview. And I might take us to the topic and ask you sort of an entry question to effective data science. What are or how do you define effective data science, and what are some of the areas that you see as important there?
Yeah, I mean, when I talk about effective data science, and we're specifically talking about data science, which is that combination of sort of machine learning and math and statistics and the business domain knowledge, right? And it's purely doing sort of machine learning and AI for a particular purpose, which is to add value to your business. And so when I talk about effective data science, it's really about saying in that sense, how do you come up with a process or a data science function that brings that value to your business? And there's a lot of excitement around machine learning, AI, and all of that. All of the businesses want to get in. The truth of the matter, though, is that it really is kind of a hierarchy, right? And there is this hierarchy of AI needs in some ways. There's an article on HackerNet as well about this. But basically, you want to be effective in each one of the stages of building that function. So it starts really with data, right? And there's a lot of emphasis on AI and machine learning because it's exciting. But the truth of the matter is that the sort of bread and butter of it is really actually good data. And how do you get to good data? You get to good data by excellent instrumentation. So that means you're literally logging everything and you're logging it well. And then you build on top of that instrumentation and you say, do I have the kind of data architecture that I need that ingests all of this information, organizes as well, and puts it into a situation that a data scientist can easily query and build models off of or have analysis to do. And you want to, of course, avoid as much as possible, doing data engineering every single time there's an iteration of modeling. And that's one of our questions in the poll, right? Like is that we had put in. And so I think in terms of effective data science, I think you want each function to be doing, what their domain expertise are, and you want as little sort of cross-functional, actual contribution. You want cross-functional cooperation, although not necessarily people leaning over and onto the keyboard, right? And I think that's where the effectiveness comes in. So if you have good data, you have good data architecture, and you're supplying your data scientists with sort of clean data, and it's never going to be true, it's never going to be 100%. But the best effort that you can get to, it minimizes the time that a data scientist, for example, would spend in making sure the data is in the shape or the form that they need and is clean, and it's it's trustworthy data that they can then put into their models and move on. And then from there, of course, it goes into modeling, and modeling it's like its own beast, right? And you obviously there's excitement again around the most complex method and deep learning and all of that. Like with many things, I think common sense and setting baselines is super important as well. So you want to construct something that starts super simple, makes sure that the assumptions you're making about your workflow and your data are correct assumptions. And then from there you build off of that and you get more complex, and you say, okay, I'm going to try more complex methods to try to push the accuracy and add more value. So that's sort of a broad overview of saying, functionally you want each one of these bits to be effective, and then overall as a process, you have trust because you've kind of built it up in a modular fashion. In the software engineering world, you have, test-driven development. And in some ways you can think of this in terms of a macro level. It's like test-driven, development, where you're basically building each little function, testing it, and making sure it's good, and then building on top of that.
That's great, man. That is awesome. And it's definitely something that at least in Australia we're grappling with, and the larger organizations are leading the charge here on exactly what you're saying, which is how to create an effective data science organization or capability within your organization, but also how to do that at scale in a way that's
right.
Effective and repeatable, and that you can trust the process, because a lot of it at the moment for us at least, it seems to be it's improving, but it's going from kind of like a cottage industry, where like you'd have a team that's trying to do it themselves, and the processes are not very well defined, and doesn't have much scale. Often the products are good, they're making business impact, but it's not something that you're getting organization, like a capability organized at scale in a way that's effective.
Right.
Yeah, except for larger organizations here.
Yeah, I mean, I think the history of data science is actually from actuarial sciences, and that a lot of like insurance companies and stuff had these departments 30, 40 years ago. I think the sort of revolution has really actually been is scale, and I work in ads, and I will actually attribute some of that to ads, right? So the Facebooks and Googles of the world, with ad revenue and the scale that they brought, meant that there was actual money to be spent in terms of developing these processes, and that's like a whole area that got developed, and because it required scale, given the size of the data that these companies were generating, and also the revenues that were being generated by that size of data. And I think it takes a level of organizational size to get to a point where the scale is necessary. And data science can be done in both that scaled fashion as well as in that kind of local fashion. And there's no harm in having something that's like, an R script that just produces a lot of value. I've seen that happen at organizations, and it can be very, very useful. Of course, as your organization grows and your data science needs grow, and you actually understand that I can produce value from doing AI and machine learning on data, that's when you say, how do I repeat this? How do I make this into a process that can be repeated and is scalable?
Yeah, 100%. And that is awesome. And that's definitely, obviously great topic for today. So do you think we should start at the input side, starting with the data quality and moving along the chain, or starting at the end? Do you have a preference?
No, we can start. Yeah, we can start in the beginning. Make the beginning the beginning. So.
Yep, brilliant. So on the data side, data quality, data input, on the instrumentation side, could you tell us a bit more about what good looks like in that domain?
Yeah, 100%. So I think I would say it's an often neglected kind of area. And I think data engineers and data architects are super important. Again, as I said, the garbage in, garbage out problem. We haven't, we've seen a lot of activity around ML ops, so machine learning operations, and that kind of thing that we talked about before. There is, however, somewhat of a dearth of tools that essentially verify how good your pipeline is, right? And when I talk about pipelines, what it means is you start from instrumentation, which means you have a system where you're logging everything. And from there, you're building pipelines that basically synthesize that information into sort of consumable, you could call it tables or hive tables or so on. And that's where you want to know that process is good. And I've seen many approaches to this. People use many tools and so on. There isn't really like a standard that I've seen necessarily for data quality. And it's actually a very difficult thing to come up with. And the reason why it's very difficult is because it's domain specific. And there's certain choices that people make in terms of, do you store your missing information as nulls? Do you store them as -1s because that's better for you? Like, there's things that you do and choices that you make that make it very arbitrary in terms of what the actual tests are. So I think one of the things that you can do as an organization, and that's sort of customized to your approach to doing the instrumentation and the data pipelines, is essentially to say, I'm going to define my own unit tests, if you want. And these are data unit tests. I mean, in software, we talk about unit tests as being, examples that we give to this test to say, verify this output given this input. And a very similar approach can be applied to data as well, because, you can understand that there's a transformation that happens when you're going from, stage A of the pipeline to stage B. And I think the good part, when you get to good, essentially means that you have enough faith that your alerts in there are going to point you to problems and be able to not go silent. So silent failures can be very, very dangerous. I mean, that's one of the most dangerous things, right? You don't know that, your table has not been refreshing for 3 weeks and you're working on stale data. Those kind of things are the things that you definitely want to avoid. And the way to avoid them is essentially to put sensible checks in place with alerting and monitoring. Though there isn't necessarily a product that comes to mind, there are lots of them. But I think it's an area that is necessary. And I think some kind of integrated method where we go up the chain, you get a weird prediction. Can you come back down and figure out where the problem lies? Is it in the algorithm? Is it in the pipeline, and so on? So we start with that from the data pipeline part, and then now if we move to the doing the modeling and saying what does good look like there. So one part of it is obviously when you operationalize a data science model, and we use a lot of these verbs that we don't have a good one: productionalize, operationalize. There are a lot of options there. But essentially, when you're doing that, what you do want to have are mechanisms of versioning, and versioning is definitely on both ends: model versioning as well as feature versioning, right? You want to know, from as a data scientist, you want to know which version of a feature I was given, and feature versioning is super important because you want to understand, was it transformed, was it not transformed, and so on. And then, most of these models have this component of regular training. And when you have regular training and you are, putting into production a model, let's say if you're doing daily training, even if you're doing weekly training, you definitely have to have some kind of, model hosting service that basically says, okay, I can keep track of which model is currently being served. And I've seen this done well in the sense that you can have model hosting services that associate metadata together with a produced model, that basically now I can go and query from the model hosting service and say, can you tell me what's the metadata, or what version does this model particularly have? And I know that I want to get the one that's the latest. So that's the latest trained one. And I think there you're doing this job well, where you're basically tracking exactly which model was being used, what was trained, when was it trained, what was the training period, and all of that kind of stuff. So that's kind of on the operational side, right? There's also like the effectiveness of your actual, doing your data science, or doing your model and saying, does it drive value or not? And there are a lot of choices to be made there. And typically what you do want to do is, again, start from the basics, right? You have a continuous regression problem, like literally just try regression, just try regression. But then you have more complex problems. So I work on personalization, and now you get into like, arguments like, should I use, matrix factorization? Should I use deep neural networks? And how should I go about setting time limits on saying how much iteration am I going to do and when is good enough? Now, this is where you bring in sort of the business acumen, the collaboration side of things, right? And some of the ways I've seen that organized is you will potentially work with a product manager, and the product manager, together with leadership and yourself, you define what you think is actually good enough when we talk about predictions. And the effective part of it is really to say, like, how soon can you get there? And I would say also with parsimony, right? Like, can you get there in the simplest means? You don't need to, go for the most complex method. And typically starting there will help ease all of the pain afterwards, which means debugging, monitoring, all of that sort of stuff. So as a simple example, you have regression coefficients. You could just look at those. There's a lot of like AI explainability tools out now as well, so you can use those for complex models. But again, starting simple is definitely better. So you don't have to go in that direction. But if you needed to, there are tools available for that as well.
It's awesome, man. And what is the start of the project look like in terms of that definition with a product owner of saying what should be done, what is the benchmark? How does that process usually work?
Yeah, so I think I've seen it done a few ways in different organizations, right? So there's sort of a bottom up and top down kind of way of how these things come about. So let's say you're working on some product and now there's a desire for a new feature. Now that new feature can be driven either by sort of the data scientist having worked already on one part of the model and noticing that, okay, we have this piece of data and I think that I can make this other thing happen, right? And we can make it concrete. So for example, we say that I've seen that I can use another piece of data to improve personalization. And but it will require, let's say, some kind of coordination with another team to make sure that it's good to be used, right? So that would be sort of a bottom-up approach where the data scientist says, I noticed there is this thing, I'm not sure if I can use it. I'm going to work with my product manager and leadership to say, is this something good to add? Can we do this? Are we good on that? And then of course there's a sort of top-down approach, which is like leadership wants to take a particular direction, and instead of showing one ad, they want to show two ads now. And so now you come back and you say, how do I rank these two ads, for example, right? And so now this becomes a data science problem that's brought to you, which is, I want the top two ads, and you have position 1 and 2, and you know that position 1 has just a position bias. People tend to click the first thing first, right?
Yeah.
So now you're going to work on that problem, and then you're going to work with your product manager, obviously, to define the requirements. Is it best to show, for example, a product that you think will have lower take rate and give it a benefit of a first position bias? Would you do that or not? These are the kinds of questions that product can help you answer, right? Because you can do the math, you can do the modeling, and you can come up with a ranking, and that ranking can be most relevant first, most personalized first, contextually the most relevant one first. But all of those choices, then you work with your product manager to say, what are these specific requirements? So
that's great. Yeah, I really like bringing that sort of that commercial lens and that business view to work closely with the data scientist. And what about approaches to get the customer's perspective in, or customer requests for new features? Have you seen good avenues to bring in the requests from customers?
Yeah, I mean, I think there's been efforts. So Netflix would be my example there, right? Like you have product recommendations, you have content recommendations. Please bring this movie back. Please don't take this movie away. Can you not make this autoplay because it's really annoying? Stuff like that, right? And it's interesting because when you live in a world where you're doing A/B testing, you really have to make sure that anecdotal evidence that you get is not necessarily broadly applied. And here's an interesting thing where I personally found some features very annoying, right? And I said, how could they possibly be winners in an A/B test? But they are winners in an A/B test. And if they're winners in an A/B test, and you're doing science-based sort of development and progression, that's the numbers sort of speak for themselves, because you are taking aggregates and you're saying that my metrics improve when I add this feature or when I don't add this feature. I would say that the customer feedback is definitely, it's an important thing to take into account, but probably A/B testing trumps that to some extent. Now, the problem though is that when we do A/B testing, right, we're testing ideas that are sort of, ingrown within the organization, like people coming up with these ideas and saying there's an A/B test. You can definitely have, customer input come in and say, okay, there's this other feature. The other place there I've really seen customer feedback work is in actually identifying like issues, right? So you'll see some kind of blog articles about certain companies where you will get text analysis of reviews on Twitter that people will use to then go back and say, oh, that recommendation doesn't actually look so good, or that part of the video was actually, had lower bit rate or something like that. So you have some problems that you can identify. And so I think you do get some input, but though I would say it's probably like a smaller part of that input. And the second part of it, that the A/B testing metrics sort of speak for themselves, right? So that's actually is customer feedback. Is this ranking algorithm better than this? I don't necessarily need to go to a user and ask them that. I can actually put it out into an A/B test and actually test whether that's the case or not. And I think A/B testing gives us that power to sort of scale customer feedback without having to actually do interviews. Though anecdotal interviews do help, and we at Netflix, for example, there's actually a consumer insights team, and that consumer insights team will run interviews and bring feedback back to the product, and that can drive features and so on. Yeah,
that makes sense. That's really good. And in your experience, is the aim of A/B testing, is it to give one set of product features to everyone, or would there be different product features that are enabled for different types of users?
So, I mean, I think the way, the idea of A/B testing is essentially to start out small and then you scale your test, right? So a lot of A/B testing involves ramping. So essentially what you will do is you will start with a very small subset, because in systems where you have revenue involved, you obviously don't want to, throw in a new feature and put a lot of people in that bucket. So you start out small, you ramp up, and as you ramp up, you actually see the effect of your test. And that's where you're saying you're applying that treatment sort of to a small set of people, and then you're growing that. If you're asking specifically in terms of the same feature, there's obviously that personalization side, right? So to some extent, you can read a tech blog article about artwork personalization at Netflix. So they're basically, you and I would not get the same cover art for a particular movie because one is better for you than me.
I've noticed that between the account of my wife and I having the same movie. Yeah, completely different. But in that case, it's essentially the same product feature. Say that in this case, the cover art that's personalized for the individual, which I guess would be one avenue. But the other one would be having different features for different types of users. Are there and do you is that something that you've seen in your experience?
Not in terms of going forward, persisting like you're gonna get this extra button forever and I'm not going to get it. That I don't think so, because you would want consistency across your product, because it's very difficult to evolve different versions of that particular product. So I think personalized experience basically means that you have a wireframe that's consistent, but within that wireframe, the content that you put in, the button's blue or the button's red depends on your preference. And I think the A/B test driven development, I mean, you definitely want to keep that consistency so that you can track performance and track the metrics as they're going up, hopefully up.
Yeah, that's great. And Georgie on the chat pointed out that that A/B testing generally helps you improve your features and your current product, but that there would be other avenues that help you create new products, and that
Right.
as you were saying, that could be bottom up, it could be top down, it could be from a market research area. Is that how you see the distinction?
Yeah, absolutely. I mean, I think A/B testing helps you test ideas and evolve systems. So fine tuning a direction that you're already on, testing new ideas as well. But then, yes, obviously there is this other creative process, which is how do we come up with an entirely new set of products? And we kind of get into the entrepreneurial area there.
Mm-hmm.
So, I mean, Amazon would be your best example of something like that, right? They have their hands in everything. So from drone delivery to grocery delivery to your slippers being delivered to, I don't know, car buying probably soon or something like that. So
right, and so have all the products, and then deliver all the products, and on the AWS side, build all the products, offer everything.
Right, exactly.
So I might close the poll now. So we had about 60% of people answered the poll. Thank you very much, and we'll go through the answers. So people should be able to see the answers now. So the first question was, what percentage of your time do you spend on data engineering versus data science tasks? And 36% of people said it was 50-50 between data engineering and data science. That's really, really interesting. And then the second highest voted was 80% on data science, or 80% of the time on data engineering, and 20% on data science. Any thoughts or comments there?
That's interesting, actually. I mean, I would have definitely expected 80-20. That's a sort of classic fit. So I'm glad to see that most of the participants here are enjoying a nice data science experience with doing minimal engineering while producing their models. And maybe I want to work where you work. I don't know.
But, I feel the same. Yeah.
Yeah, but I think it's interesting that I mean, it is one poll. I think perhaps one of the things that would be interesting to know is if things have evolved to a point where data engineering, I'm hoping their products have evolved to a point where that's now commoditized. And if that's more commoditized, then hopefully we would get to a point where we can actually get to the inverse of that, right? We can get to 20/80, where we're only doing 20% of our time engineering and then doing data science tasks for the rest of it. And that's specifically for the data science function. There's nothing, I've actually emphasized that the data engineering roles are super important for any organization.
Yeah, definitely. And it'll be interesting because as you were saying before, as the data science or as the algorithm application of algorithms in a particular organization, as that gets more automated, then the bits that would be left are around bringing in the domain knowledge into the data and the production side. Do you see any other components that would be, I guess, left in the data science arena once data engineering improves? What would people be spending their time on once the data is of a high quality and available?
Well, I mean, I think from a data science perspective, I think it affords you the luxury of diving deep into the models and really focusing on the algorithms to improve predictions and so on, right? So I think in that sense, it's the most valuable thing you can do, which is if you have a data science function, you entirely dedicate that data science function to getting you to the best machine learning solutions for your organization. And there's that automated ML side, obviously. And yes, that will evolve and it will get better. And I don't see data scientists going out of business anytime soon, though.
Yeah.
But at the same time, though, I think the next focus for this would be definitely doing things like data engineering, automation, things like automated exploratory data analysis. So it's a very interesting feature even in Google Sheets that you can see, which is you can say get data insights from it, and it will attempt to make reasonable pivots and draw figures and make averages. So you could think of it as more like a automated pivot table kind of situation, where it actually is trying to figure out a few things from your data by just looking at the table that you've provided. I mean, that's a direction in which you're saying, okay, exploratory data analysis is now going to be potentially automated, which I think is super cool, because you'll spend a lot of time doing that. But if you can actually get that in an automated way, I think that's a huge time saver.
Yeah, huge. That's great. Thank you. The second question was, what percentage of your time do you spend applying existing algorithms versus developing new algorithms? And the highest voted one was 80% of the time applying, and 20% developing, so sort of R&D. Any thoughts there?
Yeah, I think that's pretty consistent this time. I think with what we talked about, I think that again, part of doing effective data science is doing it in a timely fashion. And if you have no need to reinvent the wheel, then you shouldn't. And you can use the simplest approach. The simplest approaches are pretty commoditized, so we don't necessarily need to go in and modify them. Now, there's one part of this I would say that just because those techniques do exist, using them in a blind fashion, it can potentially work. But when things go wrong, that's when you will actually have an issue. So if you have prediction drift, if you have underestimation problems, if you have overestimation problems, you really need to understand some detail about your actual algorithm, the data going in, how you've set things up, what are the parameters. I mean, in the worst case, I've seen examples of people treating it as a black box with completely the incorrect parameters for their data set, right? And in the worst case, you can do that. So I think there is, yes, you can apply current existing algorithms, but I do think that the onus lies on the data scientist to say that I apply them in an informed way. You don't apply them blindly.
That's great. Yeah, very very wise words there. Don't do kind of like the point and shoot. And
Right. Right. Exactly. Exactly.
Yeah. Yep. That's great. Thank you. And the other question, the third question was, is there a data architect in your organization? So 50% of people said yes, 36% said no, and 14 said not sure. Okay. So almost a 50-50 split between yes and no / not sure.
Yeah.
So could you, for the people that don't know, could you tell us what would be the role of a data architect, and then some of the benefits of having one?
So I can give you a very concrete example of this one, which is like, let's say that you're somebody like Netflix that's trying to predict, whether somebody's going to click on a movie or not. Or if you're Amazon and you're trying to figure out if someone is going to click on this particular product or not. And you've received a new data source, right? And this new data source, tells you, let's say, about the popularity of a particular product. And now, yes, there's a single simple stream of data, but if, let's say that, in terms of understanding the popularity of this data, you have of this new feature, you actually have this available in multiple languages across multiple countries at different time scales. How do you organize this data to make it useful for, let's say, your predictive model, right? And now that's where the data architect's job comes in. At what granularity should they store it? How should they normalize the data? What's going to be the most effective way in which you can apply efficient joins to join it to your other data set, and so on. So if you were to do this in an uninformed way, all that will happen is that, yes, you might be able to connect this new feature to the existing data set that you have, but you will go about it in a very roundabout fashion, and you'll probably be pretty inefficient on it. And then what's worse about doing it the bad way is essentially that as this data accumulates, it's going to be a major effort to actually transform it or shift it to an architecture that's actually easily queryable and is amenable to doing data science or testing of that feature. And so that's where the role of the data architect comes in. And yes, the data engineer and data architect role kind of, the lines are blurry there. When I talk about data architecture, I really talk about how do I take this data and what's the organization of my tables? How do I connect them and so on?
Yeah, that's so it would definitely help make the data science teams more productive to bring on repeatability and scalability, because the pre-work is being centralized and you get sort of good inputs into the process.
Yeah, we haven't actually talked about even one sort of layer before the data sciences, because like we actually did talk about data analytics in the title of the talk, right? So I do actually think that like the analytics comes even before like doing the AI or the ML, right? And that's where if this new data source, let's say, was organized well, I can just put that data on a dashboard and you can now see that pretty well, right? And if you hadn't organized it, I can't even get that insight as quickly as I could if it was organized. And so I think in that sense, like you have analytics and then you have AI and all of the data architecture that's well done will help both of those functions.
I am so glad you said that. That's something that something definitely close to my heart, in the sense that I see my analytics team almost as the scouts. That they go and they're trailblazing working closely with business to find kind of new areas, help the business get quick answers and etc. And once there's a relatively well-formed or an interesting problem that sort of gets passed to the data science team, and we know that it'll take a bit longer to have something great out of the data science team, in the sense that it's scalable and repeatable and passing benchmarks and things like that. But definitely it's important the different sides and how crucial it is to have good data as the input there.
Yep.
That's awesome, man. And what would you say what advice would you say to people that are either starting an analytics function in their organization, or that they're early in their journey? What would you get them to focus on or think about? Could be approaches or roles or anything really.
Yeah, I mean, you want to start with definitely your goals, right? And you can start in a place where you say, I think that we can do this using data. And once you say that that's the case, then I really, like this sort of hypothesis-driven approach to even analytics, right? So in the beginning, you have a hypothesis. I have a hypothesis that I'm going to improve. Let's say I'm a credit card company and I want to improve my, loan acceptance that I'm giving, reducing my false positives. And how can I use my data to do that? And I think that's where you want to start with the question. And once you have the question, the solutions, it's easier to start with a question rather than starting with the data. Right. So, and I think that's very important. So if you state the problem clearly, you will actually arrive at the solution a lot earlier. And also, if you're starting an analytics function, you definitely want to start with the data. You've got to start and know that you are actually logging and you have enough instrumentation in your systems that you have the data that you need. And then once you have that, I actually do think that analytics is really the first step. Just plot some stuff, and look at it. And it can tell you so much. And that's part of the exploratory sort of data analysis part, right? Which is start with with knowing that you need to look at the data, you need to understand what the data is sort of telling you, and then you build off of that. Your approach should not be we have data, we want to do AI. I mean, that's not the approach, right? You have data, you have a particular question. Now, once you have that question, now you ask yourself, what expertise do I need in order to get this form of this data into a shape where it actually answers that question? That shape, it could take the shape of a prediction model, it could take the shape of a dashboard, or it could just take the shape of a simple plot that's plotted on a regular basis. You know, that's what the dashboard is. But yeah, so in that sense, sort of hypothesis-driven, question-driven analysis, I think helps you shape your strategy for the rest of it.
Yeah, that's great, and that definitely yeah, brings you close to the business, and it means that you're working on things that are value adding and sort of real life problems, which is great. We do have a question from the audience that I haven't jumped into, but before we do that, I might ask you, what about some advice for people who are wanting to start their career in data science? So they might be either learning data science, or they aspiring to become data scientists, or they might be people working in business in a different function that are wanting to become better stakeholders of data science and work closely with those areas.
Yeah, I think for those people, I mean, I think the advice would be slightly different for people transitioning versus people who are going brand new into data science. I mean, one thing to definitely know is that for doing effective data science, there are those three components, which is sort of your computer science skills, your math and statistics skills, and then your business acumen. And you know, what I see when people enter data science, so you know, you get a lot of science PhDs like myself who enter data science, right? And one of the reasons why it's a good path for science PhDs is because we actually do hypothesis driven you know, analysis and testing. Everything is hypothesis driven when we're doing science, and then if we're from more computational sort of areas, so for me, it was computational neuroscience. And I was my research was at the intersection of biological vision and computer vision. And so I also had a background in computer science. So I think having, you know, strong computer science fundamentals is important, especially for you to be an effective data scientist. Part of that is because you don't know where you're going to land. Are you going to land in a place where, you know, like some of our lucky attendants with, you know, who only do 50% data engineering, you may land in that situation, and maybe you don't have to do as much engineering before you can get to your data science. But at the same time, even to, you know, operationalize your models and to come up with architectures that are scalable, where you will have an input. Yes, you would work with engineers, but you're part of that engineering org in that sense because you're producing the models. You don't want to be in a place where you develop your model and you throw it over to engineering and say, go productionalize this. I mean, that's typically a model that doesn't work. And so I think having strong computer science fundamentals helps you from the start. And of course, math, statistics, and probability help you really understand the data, understand the models, and having that AI training that's part of the computer science. When you bring all of that together, and then if you've done all of that in graduate school and you come to the business world in industry, you can learn those business domains and become experts in it. But we shouldn't discount that at all. I mean, I think if you've worked in one particular area in data science for a long time, not only is it beneficial in terms of your familiarity with the data and so on, but you also have more business acumen. So you can ask the right questions, you can debug faster and so on. Now, for the people who are transitioning, I mean, if data scientists exist in your org, I think the best way is to just become friends with them, get a coffee, and actually figure out what their function is. Now, having said that, there are a lot of in different organizations, there are a number of definitions of what a data scientist is. And lots of them are sometimes not exactly like what we think of as the data science function. So, for example, I've definitely seen in organizations data engineers being classified as data scientists. And when I say that, all I
Yep.
mean is they aren't actively doing modeling, right? For me, the data scientist, one of the essential key things is that you actually do build models. And then you also have data scientists who are like doing analytics, and that actually is a blurry line, right? You're doing data science when you're doing analysis that's producing some kind of insight that's being used by business, and you could just do analytics and that would be fine, and you could have that data science. So if you are a person in an organization that's trying to transition to data science, understand what your business's data science function actually is, and are there multiple functions, and which of those functions are you interested in? Are you interested in building models? Are you interested in doing analytics? Or are you interested actually in digging into the data and organizing it and stuff? So those are all choices that you have. And you have to understand for your business, for your particular business, what is the definition of the data scientist in that org? And then from there you transition and you say, okay, yeah, this is sort of what I want to become. And then you need to obviously potentially develop some skills if you're transitioning from a very different area. So I've definitely seen migrations from business analytics into full-on data science. And so that transition probably is not a harsh one in that sense, because those people are already analyzing data and summarizing it and transforming it. And then they transition into actually doing modeling and predictive work.
Yeah, no, that's great. One of the questions from the audience was around this is from Jason. Hey, mate. Was around the recommendations that can be done, and the question is around what happens when multiple people use the same account. And in the case of Jason, him and his daughter would use the same account. Is that how problematic is that for the recommendations and personalization?
I would put that question to Jason and say, how bad are your recommendations? And if they're bad, the reason is you need to create a new profile for your daughter. So, I mean, I think in terms of personalization, like this kind of goes back to that customer feedback aspect, right? All of these systems so I do personalization at Apple, and even here, the best guess I have at what you like is the feedback you give me. You clicked, you didn't click. Yeah. Now, I have no way to know that it was you or your daughter. At least at Apple, we definitely don't know. Facebook, I can't say anything. Yeah. And so, given our privacy constraints, we don't necessarily know. All we know is that we received a click from this particular ID, right? And that's it. And so, yeah, it adds noise to the personalization algorithm. But if that's how you use the product, then maybe we're doing the right thing, So if 80% of the time Jason is using his recommenders, using his account, and 20% of the time it's his daughter, one would hope that we'd get some kind of reasonable mix of recommendations that are okay for both of you, depending on usage. But yeah, I'd recommend just getting a new profile.
Yeah, definitely. And there's one other question from Naren, she was asking about if you had the experience where you've been working on a problem, say an analysis or a development, and halfway through they stop the development or they stop the project, and what you would do in that case. So I asked her on the chat to see what were some of the reasons, and whether it was technical problems that made the solution not feasible or business value. And the scenario here, and obviously you can talk to another one. The scenario here is that the data wasn't able to answer the question or the problem in this particular case.
So I mean, is the question really about knowing when to abandon analyses, or I don't know if that's the question.
Yeah, she's asking about what would you do? How do you tackle this scenario? And it could be early abandon, which is saving effort, or trying to save it.
Okay. So if it's really about knowing when to abandon an effort, this was something that I brought up earlier, which was when you said about what does good look like, right? And part of knowing what good looks like is agreeing upon timelines and also levels of performance that are acceptable, right, within a reasonable time range. So you really want to do this upfront. You don't want to, be 8 months down the line and say, okay, well, I think maybe we didn't want to do it for this long.
Yes.
So I think, there are different projects, and they obviously it's very subjective in terms of the projects. That's one of the other reasons to start simple. If it's really taking you that long to get to knowing that you are going to fail on this, you need to fine tune your process. And it's a tired old saying in Silicon Valley, but you need to fail fast, and that's just how it is. So yeah.
Man, that is excellent, and definitely what at least what I recommend the grads, the data science grads that come in, is when they're facing a problem, before they develop sort of the understanding of how to tackle different problems and how to make it simple, specifically how to make it, the solution simple, I just tell them to build a ladder of model complexity and start with the easiest one. Start with a linear regression, do a logistic regression, do a tree, do a forest, and see what you get. But stop at the earliest one that gives you a good enough solution.
Exactly.
Farhan, this has been awesome. The hour definitely flew by. Thank you so much for sharing your insights, your perspectives. It's been outstanding. Thank you so much.
Well, thanks for having me.
Right, thank you so much again. And to the audience, thank you so much for joining. Definitely a big thank you to our sponsor, Talent Insights, who has been supporting us for quite a while to help you bring this content to you. So please show them some love. And we'll continue to do these episodes Tuesdays and Fridays. Come back for the next one. Thanks, everyone. Have a great day. Farhan, thanks so much again.